Hey everybody. So today we're going to talk about lenses. Not lenses law, but lenses like in your glasses and other places like that. Microscopes, telescopes, things like that have lenses that we're familiar with. And before we start talking about lenses and the things that define them, let's just take a look at a lens. I happen to have an old broken reading glass here with the lens in it, and you can see my image through that lens, and it's somewhat subtle, but I think you can notice that I look a little different. There's a slight enlargement of my head as you look at it through the lens as compared to not through the lens. So let's take a look at something else, maybe a little easier to define, and try to understand how seeing it through the lens affects the way it looks. So I happen to have an album cover lying around from a CD. You may not know what CDs are anymore, but this album cover, we can see the letter D there, and then there's an E right next to it. If you look through the lens, I hope you notice the D gets a little bit bigger. And of course the E would too, if we could see that through the lens. Just a little bit. It's pretty subtle. These reading glasses aren't the greatest magnifiers in the world, but they're oriented like this. But I can flip the glasses around in the entirely other direction and still make an image, as I hope you can see very quickly. A question we might ask is, how does that image look if we reverse the orientation of the glasses? So here it is one way. Here are the glasses one way. And I hope we can see the D and the E get a little bit bigger. But now I've flipped the glasses around to the other orientation. And I hope you see it. They still get bigger. So maybe we can draw a conclusion about which way the light passes through the lens. That conclusion would be that it just doesn't matter. Light that passes through one way results in a magnification with this lens. Passing through the other way through that lens is the same thing. If you have glasses, if you're fortunate enough to be one of the cool people who wear glasses, take them off for a second and put them on turned around. Put them on like that. And I hope you'll see that you can still see, maybe not perfectly, because the optometrist did a good job of putting the lenses in exactly the right spot for you, but you can still see pretty well, almost just as well as when you have them on right side out. So now let's get to the types of lenses that we're going to discuss in this class. There are two broad types. There are converging lenses, and there are diverging lenses. Now, that terminology sometimes is used a little bit differently, and we talk about these lenses under different names. We'll get to that later. Those other names are going to be quite familiar, but I like to use diverging and converging for the two types of lenses, and you'll see why, I think, in due time. So let's consider a converging lens. A converging lens we can think of as looking like this, and often in real life it really does look like that. It is wider in the middle than it is at the edges. So right here, it's wide. Out here, kind of narrow. So to help us talk about the converging lens, we're going to need a principal axis that goes right through the widest part of the converging lens. That's the part near the center. And we'll draw a center line for the lens like so. The principal axis really means the same sort of thing that it did when we talked about mirrors. Our principal axis is going to be where we identify the landmarks for our lens and our lens problem. You'll recall from mirrors that we define our mirror through a focus. Well, the same thing is true for our lenses. A converging lens may have a focus here. But think about what we did just a few moments ago with the album cover and the eyeglasses. We noticed that it didn't matter which way the light passed through the lens. Similarly, the focus for a lens is actually on both sides. And the distance from the center line of the lens, right here, to where the focus is the same on both sides. And that distance defines the focus of the lens and, in that way, defines the lens. So let's think about what we meant when we talked about the focus last time. When we were talking about mirrors and the focus, it was that place where a ray that was parallel to the principal axis would go if it were to, in the case of the mirror, reflect off of that mirror. For a lens, of course, there's no reflection to speak of, but instead refraction. So let's imagine a ray parallel to the principal axis that gets to our lens. Now, for simplicity, we're going to pretend the lens is infinitely thin, meaning the lens occupies only the space of this line. Now, of course, in real life, no lens can be like that. The ray refracts on the way into the lens, travels within the lens, and then refracts on the way out. But we're going to accept the fiction that the lens actually reaches that line and then refracts all at once. And if it's a converging lens, it would refract right down through the focus. That's, of course, for the green ray that I drew that was parallel to the principal axis. But making the comparison to mirrors, let's draw another ray and also parallel to the principal axis, and let's see where that goes. So now I'm going to introduce a blue ray, still parallel to the principal axis, and the focus being what it is where that ray also intersects with the principal axis on the other side of our lens. That is the converging lens. Now, let's think about the diverging lens. That's going to be the next topic. So we'll clear our screen and think about a diverging lens. So first of all, if the converging lens was thicker in the middle, what must be true about the diverging lens? Well, there's really only one other choice, is there? It must be thinner in the middle. So our diverging lens has that nice sort of hourglass shape to it. And just like our converging lens, the diverging lens can have a principal axis that will help define the important locations on that lens. So there's our principal axis drawn in. And of course, our diverging lens also has a focus. And just like the converging lens, a diverging lens, no matter which way you look through it, affects the rays in exactly the same way. So the focus appears on both sides of the lens. And while my picture could be a little bit better, the two foci are the same distance from the center line. So that distance and that distance are meant to be the same. Sorry, I didn't make the best picture here, but as you put it into your notes from this video, I hope you will do a little bit better job of that than I did. Once again, the important thing about the focus is that it tells us what becomes of a ray that is parallel to the principal axis. When that ray that's parallel to the principal axis goes into the lens, it refracts. That ray then moves through the lens and refracts again as it enters into the air and has a new direction upon leaving that lens. But again, for simplicity, we're going to pretend that it all happens right on this vertical green line. We know intellectually, of course, it bends on the way in and bends on the way out. But for simplicity, and this is an excellent approximation, by the way, that we call the thin lens approximation for obvious reasons, the thin lens may as well just only occupy the space of the green line. So where do you suppose the ray goes if it's a diverging lens? Where does the ray go that was parallel to the principal axis before and then passes through the lens and continues on its way? Well, that ray needs to go somewhere. It diverges away from the principal axis. The term diverging, I hope, speaks to you as meaning going away from. But it goes away from the principal axis in a very specific direction. It goes away from the principal axis as if it came from the focus on the other side of the lens. So just about there. And if I trace that ray backwards, and I will, I hope we see that it passes through the focus. I'm going to try again for a better tracing. One more, third time's the charm. There we go. So that ray traced backwards goes through the focus. And that would be true for any ray that is parallel to the principal axis. So I'll draw another one in. This one in orange. It diverges away from the principal axis in just the right direction as if it came from the focus on the other side of the lens. And once again, I'll trace that back for you. There it goes, right back through the focus. Those are our diverging and converging lenses. A lot more about that. I bet you see where this is going. There's got to be a sign convention for diverging and converging lenses. They both have focus on both sides of the lens, so that makes that sign convention a little strange, but I think we'll see. It kind of winds up making some sense. I should take a moment right now just to add one little thing. You will often see diverging lenses referred to not as diverging, but as a term we're familiar with from mirrors, concave. You will also see converging lenses referred to as, in a term that we're familiar with from mirrors, that is convex. I don't like to use those terms. I think you will see why when we discuss sign conventions coming up, but you will certainly, in any literature and resources you see, other courses you take in the future, you will see this terminology perhaps. So I didn't want to hide it from you at this point. All right, that is our intro to lenses. I hope you're excited to learn more about lenses. It's a lot of really fun and interesting things that we can see and do with them. I hope you have some lenses at home that you can experiment with, but we'll work through what we can while we can